Hello all, I'm back again. Today I'm going to go through the Databricks platform and discuss it. At the start, because I've already done a previous video on this, a lot of it's just an overview with a bit more granular detail, and then we get towards the end, especially around data governance. Unity Catalog is one of my favorite subjects. I do go a bit more in depth. So let's get started. So we're going to start with the Databricks architecture. So part one, which is the cloud infrastructure. What is it? It's the foundation of Databricks, which is built on major cloud providers such as Azure, AWS. Now, why is this important? Well, number one is flexibility. Databricks can run on multiple cloud environments. Scalability is the second one. Platforms provide on-demand compute power. And lastly, we've got security and compliance. So each cloud has its own built-in compliance tools. Moving on to the second part, so part two of the Databricks architecture is the runtime, which is the processing engine. What is it? It's the runtime layer. It consists of Apache Spark, which is distributed computing for big data processing, and Delta Lake, which is optimized storage format and provides ACID. Now, both these are very, very important as you get more and more into using Databricks. Why is this important? It ensures fast ETL, AI workloads, and SQL analytics. And this is something, as you get more hands-on, you'll understand just how important both Apache Spark and Delta Lake is. Let's move on. Part three, we've got the Unity Catalog. So what is the Unity Catalog? It is the Databricks centralized governance solution, and it provides access control, data lineage, and cross-cloud governance. And why is this important? So it prevents unauthorized access, it ensures compliance, and it improves auditability, all which are very important in any organization. And lastly, we've got workspace. So what is the workspace layer and what does it include? So we've got, it includes the data engineering. Data engineering is the ETL pipelines, the real-time processing. Then you've got data warehousing, which is the SQL analytics and the dashboards. And you've got machine learning, which is the AI model training and deployment. Next, we're going to move on to clusters. So what are clusters? So clusters is a collection of nodes. You have a driver and you have worker nodes for distributed data processing. Now, there are two types of cluster nodes. You have an all-purpose cluster and you have a job cluster. An all-purpose cluster is for interactive development and for exploratory data analysis. Now, a job cluster is for scheduled jobs. You can use this for ETL, ML, and model training. So, I mean, the way I describe a job cluster, I mean, probably more like a cron job. So, if you're familiar with the Linux environment, I'd probably put you closest to that. Now, you do also have something called cluster pools. So, these are pre-configured idle virtual machines, and all it does is reduces the cluster start time and auto scaling. It's basically just a very something that's just there idle, and when you need it, you don't have to wait. It's there. You can use it straight away, and great for automated reporting and real-time data processing. Now, notebooks, another really important part of Databricks. I'm just going to get a sip of water. So Databricks notebooks are interactive coding environments used for writing, executing, and debugging code. If you're used to, I think it's Jupyter notebooks, it's it's probably exactly the same or very similar to that. Supports multiple programming languages, as you can see, there's Python, SQL, and so forth. It is designed for collaboration, allowing multiple users to edit and comment in real time. You can share your notebooks as well. And to run a notebook, you need to attach it to a cluster. And at the end of this, I've got some screenshots which I'll show you. I was messing around and having some practice using notebooks. Okay, now on to Delta Lake. So what is a Delta Lake? It's an open source storage layer that enhances data lakes with ACID transactions, and it sits on top of the cloud storage, and it works with existing formats like Parquet, JSON, and more. So the problems with the traditional data lakes, there's no ACID transactions. They actually, I've just got for some reason I've got an extra V there. I have no idea why. That's definitely not a typo. I'll probably hit my hand on the keyboard somewhere. Anyway, back to what we're talking about. There is no ACID transactions that leads to data inconsistency and corruption. Partially committed data. So imagine having some operations fail, but the data still transferred across. So you haven't got the full data. You've got performance issues such as lack of indexing and metadata optimization. So what does the Delta Lake do? So he's got ACID transactions, right? So it ensures consistency. You've got schema enforcement, so it prevents corrupt data from being written. You've got time travel, so it supports data versioning, allowing rollback to the previous states, and it's optimized for the cloud, so it works with object storages such as AWS S3, ADLS, and the Google storage as well. Now, Databricks SQL. So why is the Databricks SQL important? So it simplifies querying, visualization, and alerting for data analysts and business users. It's designed for scalable business intelligence and data warehouse and use cases. Provides unified governance, ensuring security and access control over data. Enables real-time insights by integrating with Databricks Lakehouse architecture. Now, what is the Databricks SQL? So it's a cloud-based SQL analytics solution built on top of the Databricks Lakehouse platform. It supports high-performance SQL queries on structured and semi-structured data. And it provides an interactive environment for running SQL queries, creating dashboards and setting up alerts. And it's optimized for large-scale analytics and business intelligence workloads. And now this brings us to SQL Warehouse. So you can use SQL, Databricks SQL in any notebook that you've set up. Now SQL Warehouse is something that's really interesting. So SQL Warehouse is a managed compute resource optimized for running SQL queries on structured and semi-structured data. It is designed to support business intelligence and data exploration. Now, how does it work? When a query is executed, the SQL Warehouse allocates compute resources dynamically. So you set up the warehouse with serverless option, and we'll discuss this in another topic, probably in another video in much more detail. It uses caching and indexing to optimize performance for repeated queries, and it supports automatic scaling, ensuring compute power is used efficiently. And it's integrated with BI tools such as Power BI, Tableau, and others for reporting and visualization. Now, the great thing about SQL Warehouse, it makes things much faster, especially if you're using it for a huge amount of data exploration. So SQL Warehouse performance optimization. So you've got caching for faster queries. SQL Warehouse stores query results in memory, and it reduces the execution time for repeated queries. Just what I said a bit earlier about how quick it is. Metadata caching speeds up the schema lookups and query planning. Then you also have something called Photo Engine for query acceleration. This is an option that you can select, and it does make things much quicker. It is an optimized query execution engine built into Databricks, and it's ideal for complex joins, aggregations, and large data set processing. And then you've got concurrency and query handling. So it supports multiple users running queries simultaneously without performance bottlenecks. As you can see, that would be a huge advantage in any corporation or business that's using this. And it uses query queuing and prioritization to manage workloads efficiently. Let's get another sip of water. Let's move on to the Databricks dashboard. So once SQL Warehouse is set up in Databricks, users can leverage dashboards to visualize the data, share insights, and automate reporting. Dashboards provide a user-friendly way to present query results in tables, charts, and interactive visualizations for business intelligence and data analytics. But why use dashboards in Databricks? You've got real-time data visualization, so it displays the live results from your SQL queries. You've got business intelligence integration. It exports interactive reports without external tools. You've got automated reporting, so you can schedule the updates and send alerts based on the data changes. And you've got collaboration and sharing, so you can easily share the dashboard with your team. Let's move on to BI tools and SQL Warehouse. So instead of using Databricks dashboards, you can directly connect Power BI or Tableau to an SQL Warehouse in Databricks. This allows business intelligence users to query, visualize, and analyze data using familiar tools while leveraging the power of Databricks for the performance and scalability. So you've got the best of both worlds, something you can use a tool that you're comfortable with, and you can then use the Databricks knowing that you've got it set up with serverless compute power for SQL Warehouse and get that data in quicker. There's no bottlenecks, you're not waiting around, it's not crashing anything. It makes life a lot easier. Okay, now moving on to, I know I said that at the start, so a lot of that was just an overview. We're going to just get into the nitty and gritty of stuff now with data governance and Unity Catalog. So implementing data governance. So what is data governance? Data governance is a strategic framework for managing data to ensure its accuracy, security and compliance throughout its life cycle, and it provides policies and controls to regulate data ingestion, storage, processing and sharing while maintaining security, auditing and lineage tracking. So the key components of data governance, you've got cataloging, which maintains metadata for easy data discovery. You've got data security, which are controls for access permissions to ensure confidentiality. Monitoring and auditing, so it tracks data across, it tracks data access and usage for compliance. You've got data lineage, which maps the flow of data from this origin to its destination. And then lastly, you've got data discovery, which enables users to locate and utilize data efficiently. So Databricks, data governance in Databricks, we have Hive, Metastore versus the Unity Catalog. So Databricks initially relied on the Hive Metastore for metadata management and has introduced Unity Catalog for enhanced data governance. So the Hive Metastore was a traditional governance, data governance model. It stores metadata for tables, columns, and partitions, but it's limited to a single catalog, which is the Hive Metastore in each Databricks workspace. And access control is managed through Spark SQL, but it does not track data lineage, or provide unified governance across multiple workspaces. And as you can guess, that's probably going to be a lot more work than to keep on top of data governance and who has access to what. So metadata management in Hive, Metastore in Databricks, the Hive Metastore stores metadata for the tables, columns, and the partitions. This metadata is essential because it allows users to query large-scale datasets without scanning entire files. Instead, Spark SQL can use that metadata to quickly locate and process relevant portions of the data. However, as mentioned earlier, Hive Metastore is limited to a single catalog per Databricks workspace, unlike modern governance frameworks that allows multiple catalogs for better organization. Hive Metastore forces all data objects to exist under a single default catalog, making it difficult to scale for large enterprises that need fine-grained control over different data domains. And now, data governance in Unity Catalog. So to address these challenges, Databricks introduced Unity Catalog, which provides a modern, scalable, and secure approach to data governance. Unity Catalog significantly improves upon Hive Metastore by offering multi-catalog support. So it enables the creation of multiple catalogs, allowing better organization of data across domains. Row and column level security allows fine-grained access control, ensuring users only see the data they're authorized to see or view. You've got cross workspace governance or single governance model for managing access across multiple workspaces. Data lineage tracking, so it provides automated tracking of data movement and transformation history. And then you've got Cloud IAM integration, which supports the AWS IAM, Azure Entra or AD, and the Google Cloud IAM, aligning security with the organization's policies. So we're now going to talk about Unity Catalog. So this is an introduction to Unity Catalog. So Unity Catalog is a centralized governance solution for Databricks. It unifies governance for data and AI assets across all workspaces, and it ensures consistent access control, simplified data management, and enhanced security. So what are the key features? So you've got centralized governance for user group and metastore management. There's a 3-level namespace, as you can see here, for better data organization. And the way it's structured is you've got metastore, catalog schemas, and then data or AI, and identity management with users, groups, and service principals. You've got storage access objects for custom storage cloud locations, and you've got data sharing for efficient data set exchange. Right, so what are the benefits of Unity Catalog? So there's consistent access controls across all the workspaces, and there's simplified data management and reduced data duplication, enhanced security with centralized access control, scalable and flexible data organization with a 3-level namespace as I just shown a bit earlier, and streamlined identity management with identity federation. Right, so now we're moving on to how is the data organized in a hierarchical structure, right? So you've got metastore, which is the top level container for metadata and ACLs. Then you have the catalogs, which is the high level containers within the metastore. You have the schemas, which are the databases, which is the group related data. And then you have data itself, the assets. You've got the tables, views, machines, learning models, etc. Identity management. Unity Catalog categorizes identities into the following. So you've got users, which are individuals identified by email addresses. You've got service principals, which are automated tools or applications identified by application IDs. You've got groups or collections of users or service principals for simplified permission management. It does make life a lot easier instead of having to give permissions to individual people, stick them in a group and given the permissions for that particular group. And then you've got identity federation, which is identities created at account level, which can be used across multiple workspaces. Actually, it's really interesting topic that, and it really is. It really could do with its own video because it is quite a big topic, identity federation in Databricks. So what does it all mean in layman terms, right? So what is Unity Catalog? Unity Catalog is a super organizer for data and AI tools in Databricks. It centralizes governance, making it easy to manage access and rules across all workspaces. Why do we need Unity Catalog? Well, so the before, each workspace had its own rules, leading to confusion and inefficiency. Afterwards, you got the Unity Catalog, which brings everything under one system, ensuring consistency and simplicity. So how does it organize data? So a metastore, think it was a big box that holds all the rules and the metadata. You've got the catalogs, which are the big containers for organizing the data. So you might have sales or payroll in there. Then you've got the schemas, which are folders inside of the catalogs. And you might have a file called Gameplay 2022, a folder, sorry, Gameplay 2022, or you might have a folder called IT Support Issues. Now, tables, this is the actual data file. So it could be monthly sales, it could be staff wages. Next, as we're coming towards the end, I've got some screenshots to show you. So here I've set up an all-purpose compute power, which I've called nav cluster. And then if I've gone into my workspace here, I've created a workspace for me to get some practice, nav's Delta Lake practice. Here I've created a table. And as you can see, I've run the job. I have connected this notebook to my cluster, and there's an option for that. So you can't see it on the screen, but once you've got the notebook, it needs to be attached to a cluster so it can get the computing power. So I've created a table here, and you can see I've run the job, and it's said it's okay. Something really interesting here. So these are all divided up. So you can actually, by clicking on the code or text, you can add more code downwards. or even above it if you want to. In this case, text is what you can see here. So it's using the Markdown language, and I've given each code that I run, I've given it its own title. And it just makes it easy if you're sharing the notebook, someone can see and see what's going on exactly. A bit like commenting almost, but just with its own header which stands out. As you can see here, this is my workspace. So I've got a folder which is called Databricks Practice, and here you can see my notebook, which is Nav's Delta Lake Practice. You can create, and if it's this on the right hand side, if it's a drop down menu, folder, notebook, file, etc. I do want to thank you for your time. And I hope this Databricks presentation has been quite useful to you. I will do another video actually where I'm actually going through these screenshots, and I can show you how exactly the practical tasks are completed. So it just as an example here, so I've view the whole data. So it's a select star from product info, and this run that notebook or that particular cell in the notebook, and it gives me the information here. And then here I've got adding data to the table. So now I'm adding data to the table and running the job. So I will do a practical one for this. I do hope you've enjoyed it. I want to thank you for your time.